Hi, this is Akash Srivastav and welcome to my YouTube channel. So today I am going to start a new chapter which is chemical bonding. So uh, we have learned 118 elements in the periodic table, but we hardly find any elements which exist in the pure form. Means like sodium, you will not find sodium. It is means if you keep in air, it will do reaction with air. So it is kept in some solvent. Very few elements like the noble gases, helium, neon, argon, are found in pure form. But rest of the elements are found in a form of a compound like water, hydrogen, oxygen, two atoms of hydrogen and one atom of oxygen. They stay together as a water molecule, sodium chloride, NaCl. Okay, so in maximum 99.99% of the elements remains or exist in the form of compounds. So why is it so? Why are all atoms staying with each other? The answer is stability. Means they are stable in that position. In considering normal examples, we do things which we like to be comfortable. Sometimes we have got a bad habit of scrolling the reels on Instagram, YouTube, and we get into a comfort zone, and while scrolling we don't even see the time and the amount of videos we have watched. Okay, and also we like to do those things, we are attracted to those things which we like we do painting, drawing, dancing. Okay, so if you have passion, you will watch those videos. Means you get to your comfort zone. So everything happens for stability. Like when you throw a ball up, it will fall down because it is more stable here. The gravity of Earth is pulling it. So atoms also, when they are with another element or a group of atoms, when they are together, they are more stable. Why? They get a stable electronic configuration. Okay, so in the periodic table, when you call an electronic configuration stable, so when it has fulfilled electrons in the valence shell. What do you mean by valence shell? The outermost shell of an atom. For example, if there is only one cell, so there can be a maximum of 2 electrons. I have taught in my earlier video of electronic configuration. You can see that video. So this is the electronic configuration of helium. It is stable. Okay, since it is fulfilled. Likewise, when there are two cells, at the last there should be 8 electrons. When there is 2 electrons in the outermost cell, it is called duplet. Okay, when there are 8, then it is called octet. This is neon and this is for argon. 2, 8, 8. So this is also stable. Okay, so these are stable electronic configuration. So noble gases electronic configurations are stable. So these elements like sodium and chloride, for example, sodium has how many electrons? It has 11 electrons. Since it has 11 atomic number, 281 is the electronic configuration. You can see in your book. Okay, now is this stable? No, it is not. Why? Because in the outermost shell there is one electron. To become stable, it must have either 2 electron or 8 electron. So for sodium to become stable, it must lose an electron. Okay, then only it can become stable. Now how? Means where it will lose the electron. So we are taking chlorine. In nature, see here, there is one electron. Okay, so I am drawing this outermost electrons by a dot. Chlorine has 17 electrons, so its electronic configuration will be 287. Okay, so writing, is it stable? No, it is not, because here also there is no 8 electrons. If it loses 1 electron, then the outermost cell will have 8 electrons. If it gains 1 electron, then the outermost cell will have 8 electrons. So I am drawing the valence electrons around chlorine. See here, it is 7, 1, 2, 3, 4, 5, 6, 7. So to attain stability, this sodium gives 1 electron to chlorine and becomes Na plus Cl minus, or we can write NaCl. Okay, this is called electron dot structure. Now you see here in this case, sodium will have electronic configuration, plus means 1 electron less, so it has 2, 8, and chlorine has 2, 8, 8. So together each of them are becoming stable. Okay, so this is an example of an electrovalent or ionic compound. So what is the definition? The compound formed by the transfer of electron from an electropositive element to an electronegative element is called electrovalent compound. Okay, the bond is called electrovalent bond, and the number of electron transferred from one electron to one atom to another, either gained or lost, is called electrovalency. All these definitions you tick mark in the book. It will be very helpful. Okay, now we are moving to covalent compound. What is covalent compound? This was ionic or electrovalent compound. Now in air there are several gases, oxygen, but initially I said oxygen, hydrogen. Initially I said they don't exist in pure form. Most of the elements in the periodic table, 99.99%, only the noble gases table. But in air we find H2, O2, N2, all these. Okay, so are these not pure? These are pure. Okay, but you see here they are in the state of molecule. Okay, H2, two are staying together and not as pure atom, means only H is not there, only O is not there. Okay, these are there but this is not there. Okay, now why these are there? Because they are stable with each other. Okay, means with two atoms together is stable. Let's take an example of hydrogen. Hydrogen has how many electrons? It has 1 electrons. But to become stable, either there should be 2 electrons in the outermost cell or 8. 2, when 2 electrons, when there is a single cell only. Okay, and it is for helium. So there is a single cell, so to become stable it must have 2 electrons. So one more hydrogen with 1 electron, okay, they combine and form H2, a bond. Okay, you can represent this by a circle also. Now both hydrogens have 2 electrons. That is, here in electrovalent compound there was transfer of electrons, but in covalent compounds there is sharing of electrons. Okay, so the compound formed, covalent compound are those which are formed by sharing electrons. Okay, it has one, but now together they have 2 electrons. 2 is a stable electronic configuration. So this is the electron dot diagram for hydrogen. Okay, now let's talk about the properties of electrovalent and covalent compounds quickly. I'm erasing this. If you want, you can screenshot it. Now let me talk about the properties of electrovalent and covalent compounds. So electrovalent compounds are generally hard solids, and in this covalent compounds are any solid, liquid, gas. Okay, so they are crystalline hard solid. The reason is they have ions, and they have a force, electrostatic force, which is a very strong force. In covalent compounds, they have weak van der Waals forces among the molecules. Okay, melting point and boiling point, for the same reason, means electrovalent compounds have a strong electrostatic force of attraction. That is why melting point and boiling point is high. The same for covalent compound is low. Why? Because of the weak van der Waals forces. These all reasons comes in exams. Okay, so in the book you tick mark the reasons also. Okay, then conductors. Electrovalent compounds are good conductors of heat and electricity, and covalent compounds are generally bad conductors of heat and electricity. Electrovalent compounds. Electrovalent compounds are not a conductor in the solid state, non-conductor of electricity in the solid state, but in the molten and fused state, they are very good conductors. Covalent compounds are generally bad, but polar covalent compounds, polar covalent compounds are good conductor of electricity. Okay, means bipolar covalent compounds we means like HCl, which had some electronegative difference. There is a positive charge, there is a negative charge. Chlorine is highly electronegative than hydrogen, so it is a polar compound. H2 is not polar, H2. Okay, because they have the same electronegativity. Now electrolysis, electrovalent compound can undergo electrolysis in the molten and fused state. Okay, in molten, see I am not writing all exactly. Okay, you, this video will be more beneficial, means what do we say, it will be more helpful when you study or see this video with your book. Okay, I have said this earlier also. So electrolysis, they are good conductor of electrolysis in the molten or solution state. Covalent compounds are generally bad conductors. Reason is same, but polar compounds can conduct electricity, can undergo electrolysis. Solubility. Electrovalent or ionic compounds are soluble in water, but insoluble in organic solvent, and they are soluble in organic solvents. One more definition, which is uh, electrovalent compounds, means one more difference, are undergoes dissociation, like sodium chloride. Okay, it undergoes dissociation. Separation of ions takes place, dissociation. And covalent compound undergoes ionization, means formation of ions takes place. I am giving you an example also. Now why it is called dissociation, why it is called ionization? See, when I was writing the example of sodium chloride electron dot diagram, you saw that there was a transfer of electron, then there was formation of Na plus Cl plus. Okay, so they are already there in the compound, so there is only separation has happened. That is why it is called dissociation, separation of ions. Okay, in covalent compound, ions are not there when the compound was formed. So here the ions formed are not called separation or dissociation. Here they are called, ions are formed, ionization. Okay, so I'm giving you some questions to do. Don't worry if you can't do. I will make one more video the next day solving those examples. Thank you so much for watching.